Hi, in this tutorial, we're going to differently place our focus on another topic where we're going to use bonding as an exam, relatable question in trying to prepare adequately for the oncoming exams. And we're going to discuss how to determine the group, how to determine the valence and give reasons, and also how to demonstrate different types of bonding. In this tutorial, we're going to ensure that we talk about a bonding that's going to involve transfer of electrons from one element to another, a type of bonding called ionic. Let's take a look at the question. Elements A and B have electronic configurations of A, which is 2, 8, 1, and B, which is 2, 7, respectively. A states the group where element A and B are found on the periodic table. Turns out, if you want to determine the group where an element belongs to on the periodic table, and that you are given an electronic configuration, all you have to realize is the last number amongst the numbers you've been given. For instance, if I have 2, 8, 1, it means 1 happens to be the last number. This same one is the group where this element A is found. And if I have a diagram, I will need to count the number of electrons in the last shell or circle. So state the group where element A and B are found on the periodic table. For element A, it is first shell has 2 electrons, second shell has 8 electrons, third shell has 1 electron. So since this one is the last number, we're going to say it is found in group 1. And when given the group of an element, we always give in reference to Roman numerals, as that is what exactly is written on top of each group on the periodic table. Then for B, this is 2, 7. We only have 2 numbers. Since we start from the left going to the right, 7 happens to be our last number. So this is group 7. So we're going to say group 7 is a V with 2 capital I's. And if at all there were reasons, we would have said it's in group 1. And this is because it has 1 electron in its outermost shell. It is in group 7 because it has 7 electrons in its outermost or last shell. State the valence of element A. The valence where, as in you've been given an element, will be determined considering if you are to take, for instance, the last number. So if we've got A, which is 2, 8, 1, we're going to find that every element to be stable on the periodic table needs at least 8 electrons in its last shell. Now, in the last shell here, it means it only has 1, which means it needs extra 7. But this extra 7 cannot be gained because they will be coming from another source or another element. Instead, it can just lose this same electron which is in the last shell and remain with the one that has 8 and thereby remain stable. So this is 2, 8, 1. For B, this is 2, 7. If we can rightly observe, we're going to find that this one has 7 electrons and only is lacking 1 which can come from A. And this A, which has 1, is lacking 7 electrons which can come from B. So this is where bonding comes in. And bonding chemically is said to be a combination of 2 or more elements in order for them to be stable. So the purpose of bonding is to attain or have a stable structure. So if this one is to be gained by this one will remain stable with 8, while this one will also become 8, which will be 2, 8, 2, 8, and thereby this compound that can be formed as AB is now going to be a stable compound. So the valence is the number of electrons an element can either lose or gain in order to be stable. If it has 1, 2, or 3 in its last shell, it better loses because those electrons really needs a lot of electrons to be stable. So if this one had a 1, the valence is 1 because it can lose 1 to be stable. If it has a 2, let the valence be 2 because it can lose 2 electrons in order to be stable. And if it has a number more than 5, which is 5, 6, or 7, let it gain because it already possesses a higher number of electrons than what can be gained. So state the valence for element A. We're going to say the valence is 1. The valence is going to be written in Arabic numeral instead of Roman numeral because it's a countable number. Then give a reason for your answer. We're going to say this is because it can lose 1 electron to be stable. We're going to say this is because it can lose 1 electron to be stable. D. Illustrates the type of bonding between A and B. So for A, when A is stable, it's supposed to remain with 2 and 8 because that one needs to be transferred to B. So whenever you are showing a type of bonding that can involve 2 elements that are trying to transfer electrons to each other, where one is the recipient, the other one is sending. So we're going to ensure that we write what we can call ionic boxes. So here, when it comes to this one, we're going to write only the last shell. So this is the last shell which is going to remain. So we're going to use crosses 1, 2, 3, 4, 5, 6, 7.